Hey guys, so before we get started on the homework tonight, let's go over some main concept of dilation. As we can see, dilation is a transformation in which the original figure and the images is similar. So this is a dilation. So this image, both of them are similar, but this dilation right here made it smaller. So a dilation either makes an image smaller or bigger. That's all the dilation is. So it's a transformation that makes the image smaller or bigger. And then it talked about a scale factor. A scale factor is in a dilation is the ratio of the lengths of corresponding size of the figure and its image. All right. So all the scale factor really is, all the scale factor really does is tell you how much bigger it got or how much smaller it got. Okay. So we're looking at an enlargement of this dilation. So this dilation make this bigger. So let's say this is 2, 2, 2, and this is 4, 4, 4. Those are the lengths. So for your scale factor, the scale factor tells you how much bigger this is. So you're looking at the corresponding sides. This side and this side are the same. So you're looking at your image over your pre-image. And that's how you get your scale factor. So my scale factor is 2. And you do that to each side. But since all the sides are the same, the scale factor is going to be 2 for this image. So that's all the scale factor is. It's just telling you how much bigger or how much smaller the dilation made the image. So, and then the center of dilation is the point that is transformed onto itself by the dilation. So it just kind of tells you where the center is and where to go from there. All right, let's get started. So for the example, in the diagram ABC is similar to HJK. A sequence of transformation was used to transform ABC to HJK. So they kind of tell you that ABC was dilated about center 0 with a scale factor of 1/2. So that means, and the last thing I need to tell you guys, if the scale factor is less than 1, that means that the image is smaller. If it's greater than 1, the image is bigger. Okay? So we're looking at this scale factor, and it's 1/2, which is less than 1. That's half of 1. And that's how we can tell that the image is smaller. This is a pre-image. This is the image. This is a pre-image. You can see that this is smaller than this. All right? So for question number one just wants us to, it says, suppose that the scale factor of the dilation in the example was 2 instead of 1/2. But the dilation was still centered about 0, and ABC was still rotated 180 degrees about 0. What would the coordinates of the vertices of HJK be? So they're saying everything is still the same. The only thing that's different this time is the scale factor was 2 instead of 1/2. Now that I know that the scale factor is 2, I know that this image is going to be bigger than this. And we know that the scale factor tells you how much bigger it is or how much smaller it is. And the way to do that is just by multiplying whatever your coordinate is by your scale factor. So let's put that into practice. So for coordinate A, my point is 1, 2, 2. Oh, they tell us right here. So A is 2, 4. A is 2, 4. So when I dilate this by a scale factor of 2, I'm going to multiply my x and my y by 2. All right? So I'm going to multiply my x and my y by 2. 2 times 2 is 4. 4 times 2 is 8. So 8 prime is going to be 4/8. So when I dilate that by a scale factor of 2, my new coordinates are going to be 4, 8. I'm going to do the same thing for B. B, they tell us, is 6, -2. When I dilate this, it's going to be 6 times 2 because my scale factor is 2. So I'm multiplying my x and my y by 2. 6 times 2 is 12. Negative 2 times 2 is negative 4. And my last point was C. And that was 2, negative 2, C prime. 2 times 2 is 4. Negative 2 times 2 is negative 4. So this is me. This is what I get when I dilate this by 2, by a scale factor of 2. This is what I get. But we still can't forget that we have to rotate 180 degrees. And remember, when we're rotating 180 degrees, your x and your y become opposite. So this will make a prime negative 4, negative 8. This will make this negative 12, 4. And this will make this negative 4, 4. So this is our answer right here. A becomes negative 4, negative 8. B becomes negative 12, 4. And C becomes negative 4, 4. All right. So it says, explain how a dilation is different from a translation, a reflection, or a rotation. So with translation, reflection, or rotation, remember the size does not change. The size stays the same from your pre-image to your image. But with dilation, the size can get bigger or smaller. So that's the main difference between dilation and translation. Your size can get bigger or smaller. And for number 3, it says the coordinate of the vertices polygon RSTV are, so that's it, 2, 4, 6, 4, 6, 0, and 2, 0. The polygon is dilated with a scale factor of 3 over 2. So 3 over 2 is 3 divided by 2, which is 1.5, and 1.5 is greater than 1. So I know that this image is going to get bigger. Explain how you can find the coordinate of the vertices of RSTV from the coordinates of the vertices of RSTV. So that's R prime, S prime, T prime, and V prime. So all they're asking us is how you're going to find the new coordinates here. And we're going to do it the exact same way we did the last one. We multiply the old coordinate by our scale factor to find our new coordinate. So these coordinates, 2, 4, 6, 4, 6, 0, and 2, 0, I'm going to multiply by 3 over 2, and that's how I'm going to get my new coordinate. So all you have to tell them for this is you're going to multiply by the scale factor. For number 4, it says reflect PQR across the y-axis and then dilate it about center 0 with a scale factor of 2. Sketch the final image. All right, so let's do this. Remember, when you're reflecting about the y-axis, your y stays the same, but your x becomes opposite. So let me use this sign for opposite because I don't want to use a negative sign. So x becomes opposite and your y stays the same. Okay? So we need to do that first. Oh, I don't want to use a pen. And I don't want to get up to get a pencil. So pen it is. So I'm going to check each point. I'm going to start with point Q. Is negative 1, 1, 2, 3, 1, 2, 3. So point Q is negative 1, negative 3. Point Q is negative 1, positive 3. I'm sorry, negative 1, positive 3. When you reflect across the y-axis, your x becomes the opposite. The opposite of negative 1 is positive 1, and your y stays the same. Sorry, guys. So we're doing the same thing for point R. That is negative 1, 2, 3, 0. So that's negative 3, 0. Okay? When we reflect across the y-axis, remember, whichever axis you're reflecting across, that's what stays the same. Since we're reflecting across the y-axis, the y is going to stay the same, and the x is going to become the opposite. The opposite of negative 3 is 3. And my y stays the same, which is 0. And my last one is point P. And point P is negative 1, negative 2, negative 3, negative 4. 1, 2, 3. So negative 4, 3. So when I reflect across the y-axis, my y stays the same, and my x becomes the opposite, and the opposite of -4 is 4. So that's what we just did, reflect PQR across the y-axis, and then dilate it about center 0 with a scale factor of 2. So this is us reflecting y-axis. Now we need to dilate with a scale factor of 2. So all we're really doing is just multiplying the x and the y by 2. So 1 times 2 is 2. 3 times 2 is 6. 3 times 2 is 6. 0 times 2 is a 0. 4 times 2 is 8. 3 times 2 is 6. So these are my new coordinates. So I need to plot 2, 6, 6, 0, and 8, 6. All right, I'm going to plot 2, 6. It will be 1, 2, 1, 2, 3, 4, 5, 6. I'm going to call this Q prime. Q prime. That's what that apostrophe means. And I'm going to plot 6, 0. 1, 2, 3, 4, 5, 6, 0. So that is R prime. And then last one is 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And that's P prime. And I just connect. So I just dilated this figure and reflected it across the y-axis by the scale factor of 2, and that's it. And B says, compare the coordinates of the corresponding vertices of the final image. So we're comparing the coordinates of the corresponding vertices, so of this, and of this. And the only thing I have to tell them is that they got bigger by 2, and it's that simple. It says, for number 5, it says, in the diagram at the right, polygon A is similar to polygon W. What sequence of transformation transformed polygon A to polygon W? Now, I can tell that because this is still facing the same way, that this was translated down here. Okay? And because it got smaller, I can tell that it was dilated then. So it was translated down first and then dilated, okay? They didn't really ask us to get into the specifics, so all you really had to tell them was that it was dilated, let's say about 2 units down, 1, 2, and then it was translated 2 units down and then dilated. And the scale factor is going to be less than 1 because this image got smaller. And the last question, Tracy dilates a figure with a scale factor of 3/4 and center 0, and then dilates the image with a scale factor of 2 and center 0. Carrie says that she can get the same final image using just 1 dilation. Is she correct? Yes. She's correct because all we have to do the dilation 1 time is multiply 3/4 times 2, and 3/4 times 2 is 6/4, which is 3/2. So if she multiply the pre-image by a scale factor of 3/2, she would be doing the same thing by doing this twice. And that is it for the homework for tonight. We will talk a little bit more about dilation tomorrow, and then we'll review about all 4 transformations we learned so far to get you guys ready for the quiz on Friday. Remember, bring in your homework, the milestones review too. Make sure you bring that in tomorrow because I'm taking that up tomorrow. All right, I'll see you guys tomorrow.